I already finished first topic of mathematical logic, that is propositional logic. Next topic is propositional equivalence. I already discussed little bit about equivalence during conditional statement, that conditional statement and its contrapositive are equivalents. Here I will discuss details about equivalence. If truth value of a compound proposition is always true, then it is called as a tautology. If truth value is always false, it's called as a contradiction. If it is mixed, then it's called as a contingency. Means all true, it's tautology. If all false, it's a contradiction. If it's a mixture of true, false, then it's a contingency. Let's see one example of tautology and contradiction. P or negation P is a tautology and P and negation P is a contradiction. Let P negation P. Now P or negation P, P and negation P. There is just one proposition, so there will be two row, 2 power 1, just true and false. Now negation P will be false and true. Next P or negation P. For or, if it is false false, then it will be false, rest it is true. So true or false, it will be true, false or true, it will be true. Next is P and negation P. For and, true true will be true, rest it is false. Here true false, it will be false, then false true, it will be false. So here all truth value are true, so it's a tautology. In case of P and negation P, all truth value are false, so it's a contingency. We can create the truth table for checking whether a compound proposition is a tautology, contradiction or contingency. If it is always true, it's a tautology. If always false, it's a contradiction. If mix of true and false, it's a contingency. Next is logical equivalent. If two compound proposition truth value are equivalent, then we can say both are logical equivalent. The compound proposition P and Q are called logical equivalent if P double implication Q is a tautology. And this is the notation 3 line. Sometime we use like this 2 line, then this for logical equivalent. Also you can see this symbol sometime used for logical equivalent. So there are 3 symbols. This is one, this is another, then 3 line. Mostly we use this 3 line. Let's see one example. So that negation P or Q and negation P and negation Q are logical equivalents. This comes under De Morgan's law. So negation P and Q will be negation P or negation Q. The negation whole bracket P or Q is logical equivalent to negation P and negation Q. So when we are taking this negation symbol inside, this and or symbol are changing. So when it's and, it's changing to or. When it's or, it's changing to and negation symbol will be with each proposition. Now truth table for checking these two compound propositions are equivalent. There are two propositions P and Q, so there will be 4 rows. For P, true, true, false, false. For Q, true, false, true, false. Now P or Q, in case of or, false, false is false, rest is true. So here these two false will be false, rest it will be true. True, 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 false, true, false, true, true. Next negation of P or Q. So this true value will be false and false value will be true. Now find negation P. Negation P will be false, false, true, true. Then negation Q, it will be false, true, false, true. Then negation P and negation Q. In case of and, true, true will be true, rest it is false. Here it's true, true, then rest are false. Now check these two truth value. It's false, 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 true. Both are equal, so we can say negation P or Q is logical equivalent to negation P and negation Q. Let's see one more example of logical equivalent. So that P implies Q and negation P or Q are logical equivalent. This is also a formula. Remember this, P implies Q is equivalent to negation P or Q. We can create truth table for checking whether these two are logical equivalent or not. Let me take P, Q, then negation P. So for P, true, true, false, false. For Q, it will be true, false, true, false. For negation P, false, false, true, true. Now negation P or Q. So in case of or, false, false will be false. These two false will be false, rest it will be true. Next, P implies Q. True, false will be false, rest it will be true. Now check this truth value. It's true, false, true, true. Both are same. So you can say P implies Q is logical equivalent to negation P or negation Q. This is the truth table. True, false, true, true. If there are n propositions, then we require 2 power n rows for truth table. If there are 3 propositional variables, then 8 rows. For 4 propositional variables, there will be 16 rows. Here there are 2 propositional variables, just P and Q. So 2 power 2, there will be 4 rows. Next example 4, so that P or Q and R and P or Q and P or R are logical equivalent. This is the distributive law of disjunction over conjunction. In today's lecture, just I am showing how can check it is equivalent. How can check these two are equivalent. In next lecture, I will discuss all the laws like identity, commutative, distributive. Now there are 3 propositional variable P, Q, R. So there will be 8 rows. P, Q, R. For P it will be true, 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 4 true, then 4 false. Then for Q it will be true, true, 2 true, 2 false. Now for R it will be true, false, true, false, true, false. Next we will find Q and R. For Q and R, true, true will be true, rest it will be false. So true, 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 then true, false, 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 true, false, 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 false. Again true, true, it will be true, then rest is false. Next, P or Q and R. In case of or, false, false will be false, rest it will be true. So here 4 true with whatever here, it will be true. True with true or true with false, it will be true. Next, false, true, true, then false, false, it will be false, then false, 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 then false, false, false. Next, P or Q, then P or R, then both and. So P or Q and P or R. For P or Q, false, false will be false, rest it will be true. So for first 4 true, it will be true, true with anything, it will be true. Then false, true, true, then false, true, true. Then false, false, it will be false. Again false, false, it will be false. Next, P or R. So for first 4 rows, it will be true as P is true. Next, false and true, it will be true. Next, false and false, it will be false. Next, false and true, it will be true. Next, false and false, it will be false. Now we will do AND of these two, P or Q and P or R. True, true, it will be true, rest it is false. So first true, 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 then true, true, true. First 5 rows true, then true, false, 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 true, false, 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 false. Now check these two column, it's same, 5 true followed by 3 false. Here also 5 truths followed by 3 false. Both have same truth value, so we can say both are equivalent. It comes under distributive law that P or Q and R is equivalent to P or Q and P or R. Like this, you can create the truth table for checking two compound propositions are logical equivalent. In next lecture, I will discuss some more logical equivalents. If today lecture is helpful for you, please like, share and subscribe. Thank you.